This is a TK Academy course where the T and the K stand for Team Knowledge for architects and designers. This is one of our specialty courses and it is on the topic of physical security. Physical security refers to the measures taken to protect facilities, personnel, equipment, and resources from unauthorized access, damage, or harm. It is becoming increasingly important in building design. In this course, we are going to identify 3 components that make up physical security. We are also going to explain the concept of providing layers of protection in physical security. We'll identify the zones and describe the features of an entry control point, and identify the different types of electronic security systems. We can describe what physical security does by considering the 5 pillars that hold up physical security. These are defend, detect, deter, delay, and deny. Notice that these are not absolutes, such as stopping or preventing. That is because any physical security system can be overcome or defeated with enough time and resources. A primary purpose of a physical security system is to deter an aggressor or threat from attempting to infiltrate. When a breach does occur, secondary goals are to detect and to delay the threat so that there is time for the police or security forces to react. A fully developed physical security system includes a reactionary security force that will defend and deny access to the threat. The approach for designing and developing a physical security system should be thought of as a pyramid, where each component's effectiveness is built upon the effectiveness of the previous component. The foundation of our pyramid is physical barriers, which should form the basis of every security system. For the next level, we include lighting, which is a deterrent itself, but also necessary for monitoring systems and security forces to operate. Finally, our electronic security systems, or ESS, which provides access control, alarm, and surveillance. Notice on the side of our pyramid diagram indicates the relative cost associated with each level. Physical barriers are the most cost-effective components to put in place. As we work up our pyramid, lighting is a relatively moderate cost. At the top of our pyramid is electronic security systems, which are the costliest components to implement. In this approach, we would want to maximize the effectiveness of the physical barriers as a first step. Next, we want to illuminate our physical barriers with lighting. Lighting needs to have a support system, or a physical apparatus, to be able to mount to, which is also the reason we apply physical barriers first. Finally, we utilize electronic security systems to complete the design of our security system. With ESS being the costliest component to implement, we want to maximize the effectiveness of the physical barriers and lighting first to take advantage of ESS functionality without spending an enormous amount of money. Physical barriers come in a wide variety of types. Some of these are intended to prevent certain forms of intrusion while permitting others, such as bollards, which can prevent a car from accessing an area but allow enough space between for a person to walk through. Physical barriers can be fences, walls, doors and gates, bollards, ditches, berms, boulders, and landscaping. Physical barriers are typically placed at the perimeter of an area that you are trying to protect, and they will serve as a first deterrence to anyone who is trying to infiltrate. Physical barriers can be classified as either passive or active barriers. Passive barriers are mostly used as deterrent devices. They can include trees, boulders, berms, ditches, bioretention zones, fencing, bollards, and walls. Notice that these are all stationary items. There are no moving or operational parts as compared with active barriers. Active barriers remain idle until triggered to deploy. They are typically used in arresting behavior as a response to someone who has infiltrated through the first layer of defense. These can include traffic nets, hydraulic traffic wedges, retractable bollards, and traffic spikes. Lighting has a unique impact on physical security. Those who are trying to infiltrate or break into an area typically do not want to be seen. They prefer to be in an area that is dark where they can be hidden. Therefore, just by placing lights around the perimeter of a security system can be a deterrence to possible intruders. When designing the lighting system, location is essential. Lighting should always be placed at areas of entrances and circulation routes. The position of lights should be in front of the object, never behind it. Placing a light behind an object will create silhouettes and will be difficult to observe. The amount of light is also important. A common recommendation is 0.5 foot candles minimum at outdoor locations. Consistency of light is key. We want to avoid contrast between light and dark or between light and shadows. Ambient light is the best because it helps minimize the shadows. It does not create pockets of darkness where someone can be concealed. Electronic security systems, also known as ESS, are the final layer on top of our security pyramid. This is where technology really comes into play, and there is always new equipment, devices, and systems being developed. Electronic security systems serve three functions. They provide access control and can identify who is authorized to be in an area and who should be denied. ESS will also include intrusion detection and alarms to identify when someone is trying to infiltrate and where the attempted break-in is occurring within the system. ESS also includes video surveillance, which is being able to monitor and observe the threat or aggressor activity when someone is trying to break in or infiltrate the security system. Going back to the beginning of the course, when we talked about the pillars of physical security, one of the key pillars that was mentioned was delay. As stated before, any physical security system can be overcome with enough time and resources. The goal is to delay a breach or intrusion long enough for security forces to detect and respond to the incident. This leads us to the concept of security in depth, or SID. Security in depth is about layering security defenses to reduce the chances of a successful breach. A successful defense system is going to wrap multiple layers of protection around it. Each layer provides an opportunity for detection and response. At the outermost layer is used for deterrence and to monitor and to observe potential threats. If an aggressor is successful in breaching that first layer, then the next layer is there to contain the threat. Then another layer beyond that provides further protection. Each layer of protection delays an aggressor and provides another opportunity for security forces to defend and deny access to the asset. An example of this would be an outer layer located at the site perimeter, such as a security fence. The next layer would be the building enclosure and exterior wall construction. Within the building would be specific rooms, and room security would make up another layer of defense. Finally, within a room, there may be a storage container or a vault. That is the final layer of security that protects the asset. The first layer of any security system is going to be the site perimeter security. This is the first layer of protection and the first line of defense. For a perimeter security system to be effective, it must be continuous and enclosing around the asset or area that is being protected. Methods of perimeter security include fences, walls, berms, landscaping, and bollards. Once we establish physical security around the site perimeter, we must have a means of access for authorized individuals to be able to get in and out. Today, we are very much dependent upon our vehicles as means of transportation to and from a site. Therefore, most perimeter security systems will have a vehicle access control point. A vehicle access control point is not actually a point, but a corridor through the perimeter security. It has three distinct parts to it: the approach zone, the access control zone, and the response zone. For a vehicle access control point to be effective, it must have turnaround lanes, or also called rejection lanes, to be able to reject anyone who is not authorized to enter in the area and turn them away from the access control zone. There should be a minimum of 2 turnaround lanes. The first one is before the access control zone and the second one after the checkpoint. This is so that if anyone who has taken a wrong turn approaching the access control zone and realizes it, can self-reject or turn around and go the other way before they get to the checkpoint. The other one is just past the checkpoint, for someone who has been rejected based upon not having any proper authorization or clearance. The security personnel can have them turn around and go out the other direction rather than being granted access to the site. Any effective physical security system, as at a vehicle access control point is going to include both passive and active barriers. Passive barriers are critical in ensuring that oncoming vehicles stay within their prescribed lanes and to maintaining the control of their speed. Passive barriers that serve as crash protection should be capable of stopping a 15,000-pound vehicle traveling at a speed of 30 miles per hour. Active barriers are usually placed within the response zone to stop runaway vehicles. The corridor zone should be defined by a minimum standoff distance where nothing else occurs within that area other than the vehicle access control point. The three different zones of a vehicle access control point define what occurs within each zone and the defensive strategies that should be implemented within each zone. The approach zone is for vehicles that are arriving and approaching the entry control point. The access control zone is where vehicles are stopped and inspected to see if they have proper authorization and credentials for entry, and if not, they are rejected. The response zone is for the security team to be able to respond to any vehicle that infiltrates the first two zones and to prevent that vehicle from intruding any farther into the secure area. The goal within the approach zone is to start calming and slowing the traffic as it approaches the access control zone. The traffic calming techniques used in this area slow the speed of traffic to reduce the threat and to increase response times. Methods to this include having a serpentine or curved road approach toward the access control zone. The road typically narrows and the lanes get smaller. There may be speed bumps or changes in pavement texture. There should also be signs identifying that one is approaching a secure area and that only authorized vehicles are permitted to enter. The access control zone is where vehicles are stopped, inspected, and either granted access or rejected and turned around. This zone includes the vehicle search area and checkpoint. The vehicle search area must be covered with a canopy so that it can be operational in all types of weather. There must be a minimum of 2 vehicle inspection lanes, so if one is rendered incapable, either intentionally or incidentally, there is another lane that can remain operational. The lighting of the vehicle search area is imperative and should be illuminated to a minimum level of 5-foot candles, so that this area can be functional and used at all times of the day or night. There must also be a security overwatch surveillance system, which includes cameras to observe, identify, and record in the event of a security incident. A component of the vehicle inspection and checkpoint area is a gatehouse or guard booth for security personnel. The gatehouse or guard booth must have a 180-degree viewing field of any incoming traffic. Crash barriers, such as bollards or boulders, should be located in the front of the gatehouse or guard booth for the protection of incoming vehicle threats. The construction of the gatehouse should provide ballistic protection or bullet resistance at the viewing window and exterior wall construction. The building enclosure construction is the second layer of protection. The building exterior wall should be designed to resist forced entry, blast, and ballistic attacks. Ballistic protection strategy can include creating an obscure line of sight, which is a low level of protection for the building, a pre-detonation screen, which is a medium level of protection, and finally, the highest level of protection, which is building hardening. I had an instructor who would say that gun control was the ability to be able to hit what you were aiming at. The truth of standoff and ballistic weapons is that it is hard to shoot at something that you cannot see, so a good defense is to obscure the line of sight or screen the view toward potential targets. The line of sight is defined as an unobstructed straight line from the muzzle of a weapon to the target. Obscuring this line of sight mitigates the threat from a standoff or ballistic weapon. The main entry of a building should not face the perimeter boundary or other strategic vantage points such as an elevated hill outside the perimeter. Also, landscape vegetation can be highly effective in screening the line of sight to the target area of a building. A pre-detonation screen is a way to mitigate the impact of a standoff or ballistic weapon being fired at a building. The weapon round is detonated on the screen, and the effects of it are dissipated in the distance behind it. The screen distances vary from less than 10 feet to almost 40 feet depending upon the building construction. This may be highly effective for weapons such as rocket-propelled grenades or other such explosive ballistics, but it is also more costly and very unsightly to implement on a building project. Implementing ballistic protective materials in the exterior wall of your building enclosure provides the highest level of protection to your building exterior. These systems are typically constructed in layers, and the greater number of layers will provide a higher level of protection. Windows in a building exterior are typically viewed as the most vulnerable, and so ballistic security glazing should be considered. Within the industry, there are three basic types of ballistic security glazing: bulletproof acrylic, laminated polycarbonate, and glass-clad polycarbonate. Bulletproof acrylic is just a single layer of solid plastic acrylic. It is the most common type, but its panels are usually between 1 to 1.5 inches thick, and they have low optical clarity. Laminated polycarbonate includes polycarbonate and polyurethane in alternating layers. This type provides excellent optical clarity and weighs less than other material systems. The top performing is glass-clad polycarbonate, which is a system of layers of glass and PVB films. This provides the highest level of optical clarity and the highest level of bullet resistance. The effectiveness of any bullet-resistant material is dependent upon the overall thickness and the number of layers that are provided within each material composition. The level of effectiveness of a material in providing ballistic protection is determined by the testing performed by the Underwriters Laboratory, or UL. This test is UL 752, and it identifies 8 distinct levels of protection. These levels of protection are not from lowest to highest, but are determined by the type of weapon that is being used, the ammunition that is being fired, and the number of shots that are being fired at the test material. The first 3 levels, 1 through 3, are more commonly encountered in the private sector and are applicable to building types such as gas stations, banks, and police stations. The remaining levels, levels 4 through 8, are considered government or military grade. The number of shots that are fired at the test material can range anywhere from a single shot up to 5 different shots fired during a single test. Working through the layers of protection, we talked about physical security at the site perimeter and at the building exterior enclosure. Now we are going to talk about different types of room security. Room security typically falls within 3 different categories: vaults, secure rooms, and sensitive compartmented information facilities, commonly referred to as SCIFs. Vaults are used to secure high-value assets. They are made of extremely strong and durable materials that are difficult to break. Vault walls are 8-inch thick solid concrete with 1/2-inch diameter reinforcing bars. These bars are placed at 9 inches vertically and horizontally to form a grid. 2 reinforcing grids are placed within each wall and then are staggered 4.5 inches, so at no point within the exterior wall of a vault is an opening between the reinforcing bars of more than 4.5 inches square. Floors and ceilings are built of the same construction materials and methods as the walls. Because of their massive weight, vaults are typically placed on the first level of a building, which means that they may have floors that consist of slabs on grade. When this occurs, the slab on grade may be 6 inches reinforced concrete rather than 8 inches as the walls and the ceiling. Vaults have a single door which is made up of steel and rated as a Class 5 vault door. When the vault remains open for a frequent access, there needs to be a self-closing and self-locking day gate to provide minimum temporary security while the vault is open. Secure rooms and SCIFs are similar in their physical construction, but they are differentiated by their purpose and function. Secure rooms are for storage of sensitive items and equipment, whereas SCIFs are occupied functional areas where people are working to process sensitive information. The walls for a secure room must be full height, going from the true floor up to the true ceiling, and include an 18-gauge metal expanded steel mesh which is attached to the metal studs and underneath the layer of gypsum board. For SCIFs, walls must be the same, extending the full height, but since SCIFs are primarily used in processing information, The sound attenuation of that wall is of utmost importance. SCIF walls must be built to a sound level class 3 or 4, which equates to a sound transmission class, or STC, performance rating of 45 or 50. In both secure rooms and SCIFs, there should be a single point of access or doorway. The door must be solid wood or steel and include a combination lock. Windows is not recommended, although they are not strictly prohibited. If there are windows in a room, windows lower than 18 feet, which is measured from the exterior ground plane to the bottom sill of the opening, must include security bars or other types of physical security barrier. Other than doorways, there will be openings and penetrations into secure rooms and SCIFs for things such as air ducts and piping. Air duct penetration through walls that are greater than 96 square inches shall include security bars placed within the duct at the point of penetration. SCIFs require sound dampening through these ducts by installing flexible duct connectors, sound dampeners, and acoustical boots to mitigate the sound transmission from the SCIF into other areas of the building. SCIFs will often include annunciation alarms, which is a rotating light to indicate when the area is not secure, the door is open, or a visitor is present within the area. We now exist within the digital information age, where so much information is transmitted digitally through the electromagnetic spectrum. The Transient Electromagnetic Pulse Surveillance Technique, also called TEMPEST, is mitigative measures to prevent unauthorized transmittance of information through radio waves. For the physical construction of these spaces, the floors, walls, and ceilings will integrate radio frequency shielding, or RF barrier material, that is included on all perimeters of the enclosed surface. This is referred to as the six-sided approach, in that the RF barrier is present on all 6 sides of a room or space. A doorway into a tempest-protected area must also be an RF-rated door and frame, which includes RF gaskets between the door and frame for when the door is closed. Windows are allowed but not recommended and will require an RF shielding film on the inner surface of the glazing to prevent radio frequency transmission through a window. Other openings or penetrations into the space must be sealed and protected using waveguides, dielectric connections, and RF sealant. Communication and IT systems are vitally important in today's world. There are 2 systems that are commonly used within the federal government. NIPR, which stands for Non-Secure Internet Protocol Router, is a non-secure communication system often referred to as BLAC communications. SIPR stands for Secured Internet Protocol Router. It is a secure system and commonly referred to as RED communication. These systems have physical security requirements as well. There must be a minimum of 2-inch separation between the NIPR (black) and the SIPR (red) cables. This increases to 6-inch minimum separation for parallel lines if it runs longer than 100 feet. Within a cable tray, there may be both red and black communication cables running through it, but they must have separation of at least 2 to 6 inches depending upon the length of the cable. Sometimes these will be in completely different systems with different cable trays for each communication type. Within an IT room, there must be a minimum of 20-inch separation between the NIPR and SIPR equipment. This increases to 36-inch minimum separation in certain security settings. There are some situations where there may be completely different rooms for both NIPR and SIPR equipment that are simply known as red and black communication rooms. Entire buildings or portions of buildings where sensitive compartmented information, also called SCI, is stored and processed will either be classified as either open or closed storage. An open storage is where SCI may be openly stored and processed. Often this occurs when the entire building is rated as a SCIF. When this entire building is rated as open storage and SCI may be openly stored and processed, the network cables and conduit may be concealed within the construction of the walls or ceiling above. Closed storage is more commonly used if just a portion of the building or a single room is used to process SCI. When there is a closed storage area where SCI is stored and processed, the sensitive information must be contained within GSA-approved containers when it is not being used. When this occurs, the network cables and conduits must be within rated conduits and molding that are clearly visible and mounted to the surface of the walls and ceilings. This is to be able to inspect the communication lines for possible taps, tampering, and sabotage. Electronic security systems, or ESS, are the top of our pyramid of physical security. It is the most complicated and costly part of a security system to implement. This is where the technology really comes into play in a variety of uses. Access control systems commonly used within the industry are card access systems, also known as CAC, which is programmable and are activated with authorized proximity cards. Access control could also take the form of a keypad entry or high-tech biometric readers like facial recognition, retinal scans, and fingerprint readers. Another feature of electronic security systems is intrusion detection or alarms. Types of intrusion detection systems are balanced magnetic switch, BMS, glass break alarms, which are triggered by the sound of glass being broken, acoustical sensors that alarm when sound reaches a certain level, passive infrared sensors known as PIR, which are typically used to sense motion, and even microwave sensors. The final part of electronic security systems is for observation, or closed-circuit television systems. CCTV cameras make up the majority of this, and they fall within two categories, either a fixed position camera or a pan-tilt zoom camera. Fixed position cameras are used when there is not an active person operating or monitoring the system, and is used primarily as a recording device. Pan-tilt zoom cameras are only effective when you have personnel who can monitor and operate the adjustable features of the camera. This brings us to the conclusion of this TK Academy course on physical security. If you enjoyed this course, please give it a thumbs up and leave us a comment. Also, remember to subscribe to our YouTube channel for more videos like this one and other video content from TK Architecture.